Hey, welcome back to Fat Mama Physics. In this video, we are going to do 4.5. This is using graphs to estimate values. So, interpreting graphs by using interpolation and extrapolation, but I am going to do this version using the slope Y-intercept form method and how you can use that tool to help you interpolate and extrapolate with more precision in your analysis, okay? So I'm going to do exactly the same examples, but I'm also going to combine interpolation and extrapolation into one video because I think we can probably get both of them done anyways. So let's get started. We have a graph below, just like in our previous example. This is the distance traveled by a car over time. It is a continuous graph because even between 1, 0, and 1 hour, the car is still moving away. So, the first thing what we want to do when we get a graph, and let's say we're asked for something like estimate the distance traveled in 1.5 hours approximately. Normally you would use the graph and you would kind of make your way along the line and read the graph directly from the axes. But you'll find that given how the size of your graph, it might be very hard to give an exact value. You might have to approximate, and which is why this question says estimate. But with the slope Y-intercept form, we might be able to do a better job. Even better job if you have Excel, but that's not the purpose of this video. So what we want to do is we want to convert this graph to a slope Y-intercept form. And just a quick recap, your slope Y-intercept form looks like this. You have y is equal to m for your slope, x for your x values, plus b, which is your Y-intercept. Now, when you read a graph, the first thing, the easiest thing to identify is what is your Y-intercept. From this graph, you can see that the Y-intercept is very easy. It's right there at the origin. So where the graph intercepts the y-axis, that is when y is 0. So therefore, your b value is 0. That's the y-intercept. The next step, what we have to do is we want to figure out the slope. Because if you take a look at this equation, other than x and y, we just need to figure out b and m. Now for m, the slope, what we need to do is we need to take the graph and figure out what is something called the rise over the run, like we talked about earlier. To find the rise and the run, we're going to pick 2 points on the graph to do that, ideally as far away as possible. So the first point I'm going to pick is the y-intercept. It's the easiest because you know that one of the values is 0, which is your x value is 0. And then everything else just becomes a little bit easier to find later. So I'm going to pick another point. Ideally, this point is as far away as possible from my first point, which is, in this case, the origin. But I also want to pick points that I can easily estimate what they are. So if the point that I pick is exactly on the grid line, then that means if exactly on the grid lines, then that means it is very easy for me to read what it is. So by looking at this graph, I can see that this point over here not only intersects the horizontal but the vertical grid lines, which then if I read it on the graph, this is 2.5 hours for my x, and if I move along, this is 200 kilometers. So these are my coordinates here, which is easy for me to calculate the slope. This one's easy. This one is just 0, 0, because that's the origin. So when I go and calculate my slope, which is rise over the run, my rise is how far up I have gone with these 2 points. So imagine these 2 points, I say draw a triangle, kind of like this. Then my rise is my green line right here. Okay, that's my rise. So to find my rise, this is from the 0 axis all the way up to 200. So this is 200 kilometers. And my run is from my first point over here all the way to here to my second point along the x-axis is my run. Run, actually for this way, run and then rise is the vertical part of your triangle. So my run here is going to be 2.5 hours. So if you think about, in terms of the context of the slope, the steeper my slope, okay, the steeper my slope, the higher I have to rise per 1 unit of my run. Okay, if I'm not as steep, I'm not rising as much compared to if I have a steeper slope. So now I have my slope, and notice it's kind of like a rate. How much I'm going up per unit that I'm going across. It's like a rate. It's like a ratio of your y-axis over your x-axis. So if I calculate this out, this is 200 divided by 2.5, I get 80. And 80 is going to be my slope. Now this is, the other thing about the slope is that it also has units. If you can't put units for your slope, kudos to you, because the slope has meaning here. Take a look at our units at the top of my fraction and the units here on the bottom of my fraction. So if I had to write my units, this is exactly, I will write exactly how my units are displayed in my fraction. What that means is I have kilometers on top per over hours, okay? That just means that I have 80 kilometers per hour. That's a rate. In fact, that is a speed. Every hour, I am traveling 80 kilometers. So this is, using the graph, you can essentially just grab the equation using the slope y-intercept form. Meaning, if I write this equation out, I'm going to get y is equal to 80 is my slope times x plus b is 0. And that's it. That's my equation. Which means if I want to do A, then the rest of the questions here are going to be very fast in comparison. So I want 1.5, hey? So that just means I plug 1.5 for my time, this is my x, into the equation. I get y is equal to 80 times 1.5 hours, okay? And then I put it into my calculator. I am going to get 120 kilometers, because y represents my distance and x represents my time. I plug in my time to get my distance, 120 kilometers. That's pretty fast. Okay, so B, estimate the time it takes to travel 300 kilometers. So this one I have D is equal to 300. So D is going to be my y value here, because that's what the y means. It's on the y-axis. So I use 300 over here is equal to 80x. I need to solve for the x, so it becomes a little bit like algebra. Hey, why do we do algebra first, right? Okay, so we divide 80 on both sides to get rid of that. And we are left with x is equal to, our time is 300 divided by 80. We get 3.75. 3.75 hours, because this is an x value. And notice that we are a little bit more more precise than we were before. Very interesting. So notice the longest step was to figure out the equation. After figure out the equation for the line, the slope y-intercept form, then everything else becomes very fast and easy and more precise. So let's go to this next one here. Suppose the car maintains the same average speed. We can extend the graph to predict how far the car will travel in a given time, or to predict the time it takes to travel a given distance using extrapolation. So what extrapolation is? Oh, hey, look. Isn't this exactly the same graph that we just did? Let's double check here. So this is our origin, that's the same, and that's the other point I used to figure out the slope. It exactly 2.5 hours and 200 kilometers. So essentially, I already have the equation. I can just use it again to extrapolate even further away from my graph. Y is equal to 80x, okay? So the relation is linear, so our slope y-intercept form holds true. And in the question, it says use a ruler to extend the graph. Our equation is the extension to the graph because it can just go on forever and ever based off of my equation. And if you don't believe me, plot this out on Excel or plot this out on Desmos. Then you can see what I mean. Because let's do A together. Estimate the distance traveled in 5 hours. I use my equation, y equals to 80x. I plug in 5 hours for my x value, which is y is equal to 80, 80 times 5 hours. And that's going to give me 400 kilometers. Bam. And I didn't even have to go to the graph to draw those lines to figure out where it intersects the x and y axes. I just plug it into my equation and I get an answer. That's cool, hey? So let's do the next one. Estimate the time it takes to travel 450 kilometers. This time we're given a distance, so we plug it into y. So I have 450 equals the y. That's y. And this is equal to 80x. And we solve for the x because that's the time that we want to figure out. Divide both sides by 80, and we're going to get x is equal to, put this in our calculator, we get 5.625. 5.625 hours. And notice, we are a little bit more precise here because we know down to a few more decimal places exactly how many hours that this person took. And that's the beauty of your slope y-intercept equation model for your linear relationships, because it gives you a great tool for you to use to analyze your graph at a more precise level compared to just using lines and a ruler on a graph. But of course, it is beyond grade 9 level. If you can do this, kudos to you. And you can do so much more with mathematical modeling for your graphs, as well as your projects, whatever you ever have to do. So, thank you for watching. Hopefully you thought this was really cool and you learned something and you can use a little bit later. I wish you good luck with that. Fan Mama Physics signing out.